Hello students, I am Dr. Shilpa Kegoda, Associate Professor, Department of EC, SJBIT. Today I am speaking about the module 2, that is a bipolar junction transistor and field effect transistor. So first today we will start with introduction to bipolar junction transistor. Here the first transistor was invented in 1948 here at the Bell Telephone Laboratories by Dr. William Shockley. Transistor means a transfer of an input signal current from a low resistance circuit to a high resistance circuit. Transistor is a three-terminal device. The terminals are collector, base and emitter, out of which base is the control terminal. That is, if a signal of small amplitude applied at a base, then at the collector we get a signal amplitude in the magnified form. This is called amplification. That is, transistors can be used for current amplification. This basically there are this unipolar and bipolar transistor. In a transistor, if the conduction takes place due to only one type of carriers, that is majority carriers, then the transistor is called as a unipolar transistor. The example of unipolar transistor is a field effect transistor. Next, in a transistor, if the conduction takes place due to both electrons and holes, then it is called as a bipolar junction transistor, that is a BJT. Next, we will start with the BJT, that is a bipolar junction transistor. The bipolar junction transistor has three layers of semiconductor materials. They are arranged either in NPN sequence or in a PNP sequence. This is a transistor configuration, symbol of NPN and a PNP transistor. So the arrow is always placed on the emitter terminal and the arrow direction indicates the current direction of a conventional current flow. So next we will start with the construction of a BJT. So in the construction of a BJT, first we construct the NPN transistor as well as a PNP transistor. The NPN transistor is formed by a thin P-type semiconductor between N-type semiconductor, whereas PNP transistor is formed by a thin N-type semiconductor between two P-type semiconductors. In both the transistor types, base comes in between collector and emitter region. Base is always a thin and highly doped layer. Emitter and collector layers are much wider than the base and are heavily doped. Next, regions of operation of BJT or biased transistor. Next, biasing means it is the process of applying the external voltage to the transistor. So, the two junctions in a BJT must be biased properly in order to operate in amplification. A transistor can operate in three regions. The regions of operation are cutoff region, saturation region, and active region. If it is a cutoff region, then transistor is off. If it is saturation region, transistor is fully on. If it is active region, in between saturation and cutoff region. The biasing condition for three regions of operation can be written as if it is a cutoff region, base emitter junction will be reverse bias, collector base junction will be reverse bias. In the region of saturation region, base emitter junction will be forward bias, collector base junction will be forward bias. In the active region, for base emitter junction will be forward bias, collector base junction will be reverse bias. Next, biasing of a NPN transistor, that is in active region. In order to use the transistor as an amplifier, it must be operated in its active region. The biasing of an NPN transistor for its active region operation and the direction of the currents as shown in the figure. The operation takes place in the following sequence for an NPN transistor. The base emitter junction of the transistor is forward bias by applying a voltage VE as shown in the figure. The width of the depletion region at this junction therefore reduces. The supply voltage VCC will make the collector base junction reverse bias. This will increase the width of the depletion region at the collector base junction. The electrons in the N-type emitter will start flowing towards the P-type base. This constitutes the emitter current IA. These electrons cross the base emitter junction and enter into the thin and lightly doped base region, where they tend to recombine with the holes. As the base is thin and lightly doped, it consists of a few holes. Therefore, out of the total injected doped, it consists of a few holes. Therefore, out of the total injected electrons from the emitter, a few recombine with the holes in the base region. This constitutes the base current IB. The base current is therefore very small as compared to the emitter current. The remaining large number of electrons will pass through the depletion region of CB junction and pass through the collector region to the positive end of the external supply voltage VCC. Therefore, the collector current IC is much larger than the base current IB. Next, we will explain operation of a PNP transistor. In this PNP transistor, the PNP transistor behaves exactly in the same way as the NPN transistor. The only difference is that the majority charge carriers are holes instead of electrons. Next, holes are emitted from P-type emitter across the forward biased junction into the base. In the lightly doped base, there are few number of electrons available for recombination. Therefore, about 2% of a total emitted holes will flow out via the base terminal and the remaining are drawn across the collector by the electric field at the reverse bias collector junction. As in case of NPN transistor, the forward bias at the base emitter junction controls the collector and the emitter current. BJT voltages and currents. The terminal voltage NPN transistor in voltage terminal voltage. The terminal voltage polarities for an NPN transistor, it is shown in figure. For an NPN transistor, the base is biased positive with respect to emitter and collector is then biased to higher positive voltage than base. The base voltage VP is connected via resistor RB and the collector supply VCC is connected via RC. The negative terminals of the two voltage across the connected the terminal of the transistor emitter terminal. VCC is much larger than VB and this ensures that the collector base junction remains reverse biased. That is a positive on collector and a negative on base. Typical transistor base emitter voltage are similar to the diode forward bias voltages. So, collector voltage must be from 3 volts to 20 volts for any of a transistor. Next, PNP transistor. Next, these are the different operating conditions of a transistor. Thank you.